Now we can see another example about what we can actually do with this p-value. So what if our p-value is very small? For example, if we roll 46s in 100 rolls. So that puts us way out here under our null distribution. So we want to again calculate our z-value, which is going to be our data, 40 out of 100, minus our null hypothesis, 1 and 6, divided by our standard error, which we calculated before is 0.0373. Plug that into a calculator and we get 6.26. So if you remember from the 68, 95, 99.7 rule, that's a really big z-value. So we want to find exactly how small the probability is of being out here. On this graph it looks like it's very close to 0, but we can be more precise. So now if we plug in 6.26, click compute, we get a value that's not even shown on the plot in StatCrunch. 1.9249 e to the minus 10, which means 1.191, and the other decimals, times 10 to the negative 10th, or written out, a whole bunch of zeros followed by a 1. In this case, we reject the null as unlikely to be true. We say that the proportion of rolls that come up 6 is unlikely to be 1 in 6. But what if our p-value is fairly big? Our example of 26 is above. In this case, all we can do is fail to reject the null. We cannot say that the null is true, ever. Null hypothesis testing does not allow us to accept the null hypothesis. The exact cutoff for rejection lies somewhere between these two values, and in a later chapter we will discuss exactly how to set it.